Welcome back, my wonderful viewers. Today we are going to talk about mutually exclusive words events, still on what probability. Now, what is this mutually exclusive events? Mutually exclusive events is just trying to tell us that two events cannot happen at a time. So, for example, I'm having a die and I throw it once. You know that the sample space will be what? 1, 2, 3, 4, 5, and what? 6. So I have my set A to be, let me say 1, 2, 3, and my set B is what? 4, 5, 6, and my set C is what? Let me say, okay, let me put 3 here. 3, 5, 6, and my set C is what? Let me say 1, 2, 3, 3, 5, 6, 2, 6, 4.
Emmanuel, are you telling me the
So
truth?
this is my sample space and I have all these sets. Now for you to know that these things are mutually exclusive is if you have a probability of what? A is equals to what? 0. You know that they are what? Mutually exclusive. So let's check their intersection. A intercepts what? B. Let's check. What do they have in common? They have what? 3 in common. So A intersects B are not what? Not mutually what? Exclusive. Hope you are seeing it now. A intercepts B are not mutually exclusive because they have 3 in common. You understand? So now let's check A. A intercepts what? Let's check C. So A intercepts C is what? This is A, this is C. What do they have in common? Nothing. So not their A intercepts C is what? Equals to what? 0. Which means that they are mutually what? Exclusive. So A intercepts C is what? 0. It simply means that they are what? Mutually what? Exclusive. If A intercepts C is equals to what? 0. So when the two intersection of two sets are equals to what? 0, it means that they are what? Mutually what? Exclusive. So let's check this Venn diagram representing this. A intercepts B, A, B. So we have what's in A? 1, 2. The intersection with B is 3, 5, and what? 6. So this one is what? Mutually exclusive. Sorry, not mutually exclusive. The reason being that they have what? Intersection. You understand? So let's check this one. A and C. We have A and what? C. Our A is what? 1, 2, 3. Our C is what? 4. So this one is what? Mutually exclusive because they don't have any intersection. Their intersection is what? 0. So they are now telling us that the probability of A union B is equals to what? Probability of A union B is equals to probability of what? A plus probability of what? B. Then minus probability of what? A intercept B. Yeah, so this is the formula for what? Not mutually what? Exclusive. Now, the formula for mutually exclusive is driven from this not mutually exclusive. Therefore, the formula for mutually exclusive A union B. Okay, this one is mutually exclusive, right? Okay, I'm not even taking the reference from this A and B. You understand? I'm just giving you the formula. You can use any letter. You get? So A union B is equals to probability of what? A plus probability of what? B. As simple as that. So this is for what? Mutually exclusive. Mutually exclusive. This is for what? Not mutually exclusive. So let me give you how we got this formula. Now, for example, I want to find whether this one is what? Mutually what? Exclusive, or from this thing I wrote here now, I have the formula P, probability of A union B is equals to. Now, from this set, they told us that is equals to what? Probability of what? A. And probability of A is what? How many letters are here? How many numbers are here? 1, 2, 3. Which is what? 3 all over. The sample space is what? 6. Then plus probability of what? How many are here in B? 3 all over 6. Then minus probability of what? A intercepts B. A intercepts B is what? A intercepts B is what? We have what? 3. So how many 3 are here? A intercepts B is what? 3 only. You understand? Because 3 is here. 3 is also what? Here. So we are having what? How many 3? 2 what? 3. It's trying to show you that the intersection, what is in common between A and B is what? 3. So we are going to have what? 1 over the sample space is what? 6. So we are going to have probability of A union B is equals to, LCM is 6, 3 plus 3 minus 1, which will give us what? 5 over 6. So that's probability of what? A union B. Let's check whether we are correct using normal union of sets. Probability of what? A union B. So that we know whether we get the same answer. This is what? A union B. A union B means bringing A and B together without anything repeating. So we are having 1, 2, 3, 5 and what? 6. You see it now. Nothing repeated. 1, 2, 3, 5 and what? 6. Now, this is what? A union B. And probability of what? A union B will now be what? 5 all over 6. The total possible outcome, that's the sample space, which is 5 over 6. Do you see that they are what? Corresponding. So they are what? 5 over 6. So now let's go for this formula. Let's prove it. Probability of what? Probability of what? A. Okay, now we are going to use A union what? C. A union C, because we have numbers assigned for C. I just use this one because of so that you understand it, using this same variable, these same letters of English alphabet. So A union C is equals to which one are we going for? Okay, let's do it normal way first. A is 3, right? A union this thing is what? A is what? Remember the formula. It will now be P of what? A, then plus P probability of what? C. So P of A union C will give us what? Probability of A is what? 3 over 6 plus C is what? 1 over 6. So we are going to have what? 3 plus 1, which is what? 4 over 6. 2 here 1, 2 here 3. So we are having 2, right? Now let's use normal way. Then P probability of A union what? C will now be union of A and this will be 1, 2, 3, right? Sorry, 1, 2, 3, comma what? 4. So we are choosing 4 numbers out of what? This 6 sample space. So we have 4 over 6. This means 4 at most. So we are choosing either 1, 2, 3, 4. So 4 over 6, which is what? 2/3. So this is all about mutually exclusive what? Do you now see that okay? Do you now see that if we still want to use this formula now to get our mutually exclusive, we can still use it. So we are going to have probability of what? A is what? 3/6 plus probability of B 1/6 minus probability of A. It will now be probability of what? A intercept what? C, which is what? -0, which will still give you what? This value. So that's it. Thank you for watching and may God bless you. Bye bye.